video will cover the practice exam 1, part B. And this video is being recorded during the spring of 2018. However, we're going to go over as the practice exam of that same exam that was given in the spring of 2014. Don't forget, there's another video of the exam that was given on 2015. So no pressure, but you guys have no excuse to get a bad grade. On the part A, I recorded that with my second period, and I explained every problem step by step, so I strongly suggest that you watch that. The link is on the mark. So then we're going to move on here to problem number 4. And hopefully my second period get to watch this part. And so we start by, we have a carousel, just like you guys. And the outer row of animals is 20 feet from the center. So I'm going to start by drawing the situation. And we also have, so outer row and inner row, so they're closer to the center, right? So let's say the center is here, and then we have 1 circle, 2 circles. It's not to scale, hold on. So let's see. That one's 10. Okay, so that makes more sense. So if this part right here is 10 feet, and then the radius for the big circle is 20. Okay, so the carousel is rotating at 2.5 revolutions per minute. So remember, that means that it's going around 2 times, and then half of the time, right? Something like that? Okay, around the circle. And so when we have things like this, we have to go from revolutions to radians first. From revolutions per minute to radians per minute. So that will be the first step, okay?
So would it be 5 times?
Well, yes. So let's convert that. So 2.5 revolutions in 1 minute. And we know that we want to cancel what? Revolution, right? Revolutions on top, so we need to put 1 revolution is equal to 2 pi, right? 1 turn is 2 pi. You guys know that very well by now. So here the units, of course, will cancel, and then we will get 5 pi. If you multiply 2.5 times 2, we will get that 2 pi radians per minute. Now, that's not the question at all. The question is, what is the difference in feet per minute in linear speeds of the animals in the outer and inner rows? So we actually have to solve 2 problems and then calculate the difference by subtracting, right? So which one is going to be going faster? The one with the inner row or the outer row? Outer row, right? So like the horses who are, in fact, this is like the whole row. So the horses who are perhaps over here will go faster. All right, then the ones that are here. Yes, because they all have to keep flying up. Oops, no, that one doesn't go right. Okay. So the formula for linear speed, linear speed right here, is going to be, it is the angular velocity times the radius. And then the angular velocity was, I remember the formula. Does anyone have 4.1 available? So remember the W looking one, that what it's what? Row? Go thing? I know, I remember. It is the radians per time, I believe. So per minute. Does anyone have formula? I can just check from the book. I'll just check. You found it? Okay. Okay. So the formula is, yes, that is correct. Okay, so first let's find the angular velocity. Now, could you use formulas during the exam?
No. Absolutely not.
Okay, so let's find the angular velocity first for the, if r is 10 feet, then we're going to find the angular velocity for that. And so that will be the degrees, the radians per minute here. So 5 pi divided by 1 minute, 5 pi radians. So that will be this part here. And then times the radius. So for the radius in this case, we will use 10 feet. Okay, so in this case, we will have 50 pi feet per minute. Now, to find the other one, where the radius is 20, what is the only thing you have to change? Radius, that's it. So here will be 5 pi over 1 minute. That is this part of the formula divided by 1 minute. That would be the angular velocity into, oh, I'm sorry, this is so incorrect. Just the variable, I'm sorry. This should be the velocity. Because I'm already saying this 1 times this one. Okay, I'll explain. The angular velocity, if the radius is 20, the angular velocity will still be 5 pi, because we need this formula, the angle measured divided by the time, and we have that here. That is the same for both circles. Remember, the angular velocity is the same for all horses. They're covering the same amount of radians or revolutions. But then when we get to the linear velocity, that will be the angular velocity times the radius. Then we get the angular velocity, this part, from here. So it's 5 pi over 1 minute, and then times the 20 feet for the outer circle. And so the linear velocity ends up being 100 pi feet per minute. Okay, so to answer the question, what is the question? What is the difference in feet per minute? So what would that be? 50. So the answer to the question, what is the difference? That will be 50 pi. So don't forget to include pi, 50 pi feet per second. That is because, you know, we subtracted 100 pi feet per minute. Oops. That should be minute, not second. Remember, 100 minus 50, and we get 50. Okay, now let's move on to problem. Well, let me give you a few seconds to catch up. Yes, so formulas you need to know for sure are here, this one. Also, this one is very important that you know it, the arc length. And please make sure if you don't watch the video, because you don't want to or you forget, make sure that you convert to radians. And on the first part of the video, I actually went over what are the most common mistakes so that you guys don't make them, okay? So now go to your problem number, let's see, 9. And I believe, no talking please, I believe the other video, the other practice exam, I believe it has a sine graph instead of a cosine, so it will be good for you to see both, okay? So then what it says, first of all, you have a cosine graph, the period, and then you're asked several things, right? The period, the amplitude, the domain, the range. I want you to notice that for both sine and cosine, the domain is the same, all real numbers, okay? And the range, it will be the same, but it depends on the amplitude, right? Mm-hmm. So what is the amplitude for this cosine function? 2, right? Very good. What if I had a -2 cosine of 2x? It's still 2 because we take the absolute value of that number, and so the amplitude is always positive. And sorry, I wrote it on the wrong place. That's part B. So the amplitude is the absolute value of 2, which is 2. It's always positive because it's the distance. It's actually half of the distance from the min to the max. Okay, so since our amplitude is a 2, that means that the range, our outputs, will be from -2 to +2. And that is because there's no vertical shift, right? Don't worry, on the exam, I will not give you a vertical shift. It's fine. Okay, then let's worry about the period. Now, this little number here tells us the amplitude, right? But the number that is here is going to change the period, all right? And so that is what we call B, the constant B. So the formula says, yeah, to pi over B. So
No,
yes.
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 So
yes, it is pi. So what does that mean? That it's going to take a full wave to complete one period. So now, this is the difference of the two parent functions. And remember, you're not going to have a graphing calculator with you. So the sine function, no talking please. The sine function, very basic form of it is you find the 3 key points, the 5 key points first, you find the 3 intercepts, and then you find a max and a min. Like that. For the parent function, the max happens at 1, the min happens at -1, correct? Yes? But when we talk about cosine, that is sine, yes. But you don't know what I'm going to put on the test. And don't ask me because I really make the exam the night before. I'd like to do that. So don't ask me how many questions, what's on the test, nothing. There are questions on the other practice exam that are not on this one. So that's why I encourage you to, because I don't know what I'm going to put in there. It's just how I feel that day or night. Okay, so let's talk about cosine because that's what you have here. So cosine, the parent function, it looks like this. This is 1. And then we have the other max, so we have the 2 max, and this is the equation for that. Just the parent. And we know the complete period for the parent function is 2 pi. Yes? Do we agree with that?
Yes.
Now, do you remember what happens in between the 2 max? The minimum. Very good. So that's at -1 here. And then in between a max and a min, we have x-intercept. So this should be pi, right? And then here we should have pi over 2. So that will be x-intercept. and 3 pi over 2. Great. Like that. That is one complete period. All right? So we're going to go back to the equation we have. And so now that one is telling us that the amplitude is going to change from -2 to 2, but also the period is going to shrink. So it's going to be from 0 to pi, right? And sorry, those will not be intercepts. Those are going to be the max and max. And then right here we'll have a min, and then intercept here and intercept here. And so it will look like, oh, sorry, actually here. Max and max. It's such a mess.
There's a graph.
Yeah, I know that. I just want to compare it. And then I'll tell you how to label your axes properly. Okay, so I'm going to just graph the other one, and then I'll graph it down. So the max is here at 2. The period ends at pi, so that's another max. Right in between, we'll have the min, which is at -2, not at -1. And then right in between, we will have some x-intercepts. Yes. Do not like this graph, but yes, that's how it looks. And this one says to graph how many periods? Is that 4? Yes, right? Yeah. 2 periods. 2 in the positive and 2 in the negative. So if I wanted to get the full points, I will have to continue my way. Right? Okay, so how are you going to do that? Very easy. You're going to label the x-axis to your convenience. Okay? And so if I forget, I'm going to try to change the axis so it doesn't have any numbers. But if I forget, just ignore all these numbers here, okay? And so this is what I will do. So let's just ignore those numbers. Don't even think about it. So we know that I need from 0 to pi. So I'm going to put pi here. That will be 1 period. Then I need another period, right? 2 periods on the right side. So right here, what should I put? For convenience? 2 pi. Now let's mirror that on the other side of the x-axis. So here is -pi, and here you have -2 pi. There we go. Use your y-axis since let's just keep it like that, 2 and -2. And then so our first period is going to go from 0 to pi. Now, you notice how the graph does not have a negative sign, right? It's just 2 cosine of 2x. So because of that, we start with the max, right? At 2, 1 at x equals 0 and 1 at x equals pi, because that's where the period ends. Then what happens in between 0 and pi? Minimum. Very good. And then right in between, what happens between a min and a max? Intercept. Do I even care that you tell me the little fractions here? Not really, as long as you have, you're estimating good, your midpoints, like that. Oops. And then it will come back again. So right here at pi, there's a max. What do you guys think will happen at 2 pi? Another max. What happens in between, and this is, by the way, 3 pi over 2, we'll have a min. And then intercept here, intercept here. Yes, are we good? And then we're going to do the same thing on the negative x-axis. So right here, max, and then at -pi we have another max. Because we established from the beginning the period was pi. And then what happens right in between? We have a min, intercept, intercept. We need one more period on the left. So another max, another max. Guys, are you taking notes? And then, right in between the two max, you have the min. Then we have intercept, intercept. When you connect the points, make sure they look curvy, okay? What I mean is, like, I don't want to see like straight lines, like absolute value graphs. Okay, so that right there is the graph of f of x. What would have happened if, for example, don't write this down, but if I give you -2 cosine of 2x?
Do we start at the minimum?
Correct. So instead, you will start with the min, and then your graph will be like reflected across the x-axis. Okay? Am I going to give you a reflection? I don't know. It depends how I feel Thursday night. Okay, but I will not give you a horizontal or a vertical shift, I promise. Now it says here to graph. So that was 4 points right there for having that graph. Now it says to graph the reciprocal of it. So what is the reciprocal of cosine?
Secant.
So g of x will be 2 times secant of 2x. It's so easy to graph. So remember, anytime cosine has an x-intercept, the secant will have an asymptote.
When it's minimum,
And what were you saying? If you have a min, parabola.
opening down. The maximums have parabolas opening down.
Very good. And then, just don't touch the asymptotes like I'm doing. That's actually bad. Another max, so you have a parabola opening up.
And it'll always be like that, right?
Yes. But if I give you a sine graph, and if I ask you to graph the reciprocal, the graph will be the same. You just got to draw asymptote. But then we're not talking about secant. What will be the name of it?
Cosine. I mean cosecant.
Cosecant. So sine goes with cosecant, because you also got to write the equation. You guys see that? And that is worth 2 points. 1 point for the graph, 1 point for having the equation of the reciprocal. So make sure you read the instructions. I'm gonna give you both periods for it. I still don't know how I'm gonna do the break part. I'm probably not gonna give you a break. Like I will give you the break until you turn it in. Okay. Now let's move on to problem 11. So easy. So you have a tower that is 200 feet tall. What type of tower? We don't know.
Eiffel.
Okay. I don't know how it's on. Yes, that's the closest. So it is 200 feet tall. And to the nearest degree, find the angle of elevation. So that's kind of like the problem you asked me earlier, right? And then right here we have, 50. Just put a little 50 feet from the base of the tower. So let's pretend this is the base. From the base, we go 50 feet. And then we want to find the angle of elevation. And so that will be the angle that is formed with this line, with the ground. And it goes up to the top of the tower. That's angle of elevation. If we talk about an angle of depression, it will be something like that. Like from the tower down, actually. That's a great point. So from here to here, that will be the angle of depression. Okay, so we have 50, we have a 200, and with respect to that angle, we have the adjacent and the opposite, or the opposite and adjacent. So you all know what function we're going to use? Tangent, because opposite is 200, and adjacent is 50. I know my drawing is not to scale.
It's okay.
And then, so to find tangent of theta, we will have to do the tangent inverse of that function. I mean, of that ratio. Because oh my goodness, I don't have a calculator. And does it say in degrees? To the nearest degree.
Oh, yeah,
But do we do it by hand? We did by hand, right?
Well, I will have to give you something that you guys can do by hand. So it will be like an easy one. If that, I might not even give you a problem. Probably not. I don't know. But tangent inverse. So tangent inverse of 4. What is it? I don't know. Or I don't know. Or I don't like people telling me what to do. If you tell me to do something, I'm probably going to do the opposite. Yeah. Okay. All right. Anyway.
75.
75? Thank you.
Sorry.
75.93?
Yes. I mean 96.
Oh, right, whatever. If I will not give you a problem that requires the calculator. Okay. If I give you a problem like that, I will probably make you use sine and use one of the common angles. Like something like
45.
What if this was you had to get like the sine inverse of 1/2? No. What degree has the sine positive 1/2?
Oh,
My favorite.
it's pi over 6, pi over 6.
5 or 6 or 30 degrees. Yes. So I'll give you something like that you can do in your head. So like if you end up with like a sine inverse of 50 over 100, you know that's 1/2. So then you should be able to tell me 30 degrees.
Or pi over
Right?
6.
Or pi over 6. Okay, now number 12. Number 12 requires a lot of thinking. Okay, so we have two cities, city A, city B, and we have a plane that flies from city B to city C. Oh, so we have 3 seats. Okay,
Oh.
so let's just like put some points. A
Nice.
and B. Well, we don't really know if they're like that, but okay. So let's see. One of the planes is flying 850 miles at a bearing of north 58 east. Okay. Oh, from city A to city B. I get you. Okay. Sorry about that.
Wow.
Okay, I'm gonna start again. Because this is how you guys will feel. So from city A, this is A, and then we're gonna go at this bearing, north 58 east, and we will arrive at city B. Okay. So that's the north-south line, right here, origin. So look at my marker. So from here, 58 degrees east direction. So we're a little over 45. This angle is 58. And then
it's 850.
850, so the distance magnitude, if you want to think about it as a vector, 850 miles. So then it arrives at city B. Then from city B, so that's the new sentence, from city B to city C, the plane flies 960 miles at a bearing of south 32 east. So we draw our north-south line, and we have to go south 32 east. Yes, are we on the same page? Let's do that. Right. So this angle here is 32. All right, and how long? 960, right? So it has to be bigger than the line in black. So just a little bit bigger. So this is 960 miles. Okay. And that is city C. Now, the question is, so if you notice the worth 6 points. Find to the nearest tenth of a mile the distance from city A to city C. So that one, right? What? I think so.
What? I thought it was only for.
It looks too easy. How do you guys know you can do Pythagorean?
Because
But do you know for sure
don't
this is
you
a
need-
right angle,
Yeah, it's not
a right triangle?
I got it.
No. I'm going to tell you why it is. First of all, we haven't covered triangles that are not right triangles. We're going to do that in chapter 6. And yes, it is because, let me think about it. Ooh, I just saw something. Do you guys see my 2 north-south lines?
Yes.
They're both parallel. And then we have this transversal right here. I'm going to trace it, okay? And then it says this angle right here is 58.
So that means that.
So this one is also 58.
That's 32.
And then this one is 32.
You saw that? You saw that video?
That's what I was saying.
So that's 90, right? Yeah? Nice.
That's
nice.
80.
So this one is 90 for sure.
We get a break.
For sure. So we could do Pythagorean theorem, yes. Should we solve for A, B, or C?
A, B, C, D.
What? A, B, or C?
Are we looking for a side or for the
We're
hypotenuse?
looking for
Hypotenuse because it's opposite to the biggest angle, which is 90. That's always the hypotenuse. So C will equal the square root of 850 squared plus 960 squared.
True. Yeah.
If I give you a problem like that, you could just leave it like that. You don't have to simplify. If you were to need a calculator, of course, like I'm not gonna torture you like that. Okay. Now, what is the bearing from city A to city C? Very interesting. Let's find where we're going from A to C. Okay. Because that will be the answer will be different if it was from C to A. Okay. So again, from here to here. So north-south line. Should I use north or south?
South.
Wait,
South.
if it's a right triangle.
Well, look. Well, yeah. Go ahead.
If it's a right triangle, couldn't you just subtract 58 from 90, and then subtract whatever you got there?
So is this
Yeah.
one? Is this one 58?
No.
180 minus.
Oh, wait.
and then you get
Maybe.
that, so.
Maybe it is. Maybe it is.
For the triangle should equal 180. So subtract 90 from 58 to find that missing angle next to your origin. You add it to the 90. Those
Okay.
two-
Okay. Wait.
Yeah,
wait,
that's
wait.
that's.
So tell me again what you're thinking about.
Okay, so 90 minus 58.
For this one?
Yes.
Okay. So that will be the 32, correct?
It's 58. It is 58. You're
90 minus 58, you get 32, right?
Yes.
And then what else can we see?
It has to be 58. The other side.
This one?
Yeah, and I already did it.
Yes.
58. No, for the C bearing.
Okay. How can we get this angle for sure? Since we know all sides of the triangle.
use
we have
sine?
the opposite, and we have the, to this angle right here,
Could you use sine or cosine?
and the adjacent. So let's use tangents. Oh,
Oh,
whew. Opposite is 960. Hold on, this looks ugly. I'm sure we could also get it from the parallel lines, right?
Yeah.
I think so.
I think so.
Thank you, Chris. So tangent of that angle, we don't know, let's call it beta, is gonna be the opposite 960 over adjacent, which is 850. We could do a tangent inverse of that. Can someone do that, please?
With a calculator?
In degrees?
Yeah.
Over 48.47.
This one?
Yes.
Really? Wow.
What is it?
So 48.47 together, right?
Yes.
So then if we subtract the 32, so just put minus 32,
16.47.
so then it wasn't 58. So this beta 15.47,
16.
15.16?
No, 16.47.
Okay. So that angle was 16.47.
Yes.
Okay, so we do have to use like an inverse for that.